Chemical properties. The three-membered ring in epoxides is a highly strained ring, and hence epoxides readily undergoes a large number of ring opening reactions. These reactions are catalyzed by both acids and bases. For example, in ethylene epoxide, hybridization of oxygen as well as carbon is sp3. During the formation of a three-membered ring, there is a large deviation from normal tetrahedral angle, and hence the molecule is highly strained. The carbon-oxygen bonds present in epoxides are highly polar with a negative end on oxygen atom. They readily undergo ring opening reactions. These ring opening reactions are catalyzed by both acids and bases. Acid catalyzed ring opening reactions. First one, reaction with water in presence of a dilute acid. Ethylene epoxide is converted into ethylene glycol on treating with dilute acid. The mechanism of cleavage involves following steps. First of all, epoxide is protonated by hydronium ions present in the medium. Nucleophilic water molecules are added to one of the ring carbon atom. Simultaneously, carbon-oxygen bond undergoes cleavage. Deprotonation gives a final product. This is called oxonium ion. In the second step, water molecules approaches oxonium ion from a side opposite to oxygen atom, and hence in the case of cycloalkenes, this method gives trans isomer of vis-diol. In this reaction, exclusively trans isomer of cyclohexane 1,2-diol is obtained. Reaction with alcohols. Ethylene epoxide on treating with ethanol. In presence of dilute acid, H plus or H3O plus gives CH2OH, CH2O, CH2, CH3. 2-ethoxy-ethanol is formed. Mechanism of this reaction is similar to addition of water in presence of acid. Reaction with hydrogen halides. Ethylene epoxide on treating with hydrogen halides like HCl, HBr, etc. to form corresponding halohydrin CH2OH, CH2Br. This compound is ethylene bromohydrin or 2-bromoethanol. Mechanism of the reaction. First stage, oxygen atom in ethylene epoxide is protonated. Second step, Br minus is added to one of the carbon atom, giving a ethylene bromohydrin. The addition of a bromide ion take place from a side opposite to oxygen atom in the oxonium ion. So in the case of cycloalkene oxides, trans isomer is formed. It is a trans 2-bromo cyclohexanol. Reaction with acetic acid. Ethylene epoxide or epoxyethane on treating with acetic acid, glycol monoacetate is formed. Reaction with hydrogen cyanide. Cyanohydrins are obtained. Ethylene cyanohydrin. In IUPAC, this compound is named as 3-hydroxypropanenitrile. Mechanism of these reactions are similar to the mechanism of addition of HBr with ethylene epoxide. First step protonation, second step addition of nucleophile. In the case of acetic acid, acetate anion will be the nucleophile, and in the case of HCN, cyanide ion will be the nucleophile. So these are examples for addition reactions involving ring opening. These are all catalyzed by acids. Second, base catalyzed ring opening reactions. First one, reaction with water in presence of a dilute base like NaOH, or addition of water. Ethylene epoxide on treating with water in presence of a dilute base gives ethylene glycol. Mechanism of the reaction involves following steps. Nucleophile is added to one of the carbon atom. In the next step, O- accept a proton from water. In this step, catalyst is regenerated. Second, reaction with alcohols. For example, ethanol in presence of corresponding alkoxide as a base. Ethylene epoxide react with ethanol in presence of sodium ethoxide gives 2-ethoxyethanol. Mechanism is similar to the addition of water. Reaction with ammonia. Beta amino ethyl alcohol is obtained. That is a 2-amino ethanol or a beta amino ethyl alcohol. These reactions are examples for base catalyzed ring opening reactions given by epoxides.